In this video we're going to be looking at linear modelling with regards to problem solving a particular word problem with some information. Now this is very similar to the last video in which I uploaded. And the question reads, the height of a tree when it was initially planted in the ground was 0.5 metres. If the tree grows at a rate of 1 metre every year, how tall will it be in 10 years? So to start the question, what I did was I created a graph, and on the x-axis of that graph I put the independent variable. Now the two variables in the question are going to be the height, meaning the height of the tree, and the time in which the tree was in the ground. Okay, so we've got time and height in which we need to place on the x and y axis as independent or dependent variables, and time is generally our independent variable. If you think about it, the height of the tree is completely dependent upon how long the tree is in the ground. Thus why this is our independent variable. What I then noted was at time 0, this here represents when the tree was planted. And when the tree was planted, how tall was it? Well, it was half a metre. Now here's our metre mark. Therefore, this represents half a metre, so I put a cross at that point and wrote the coordinate 0.5. I then went back to the information in the question and noted that it provided me with this rate of increase of 1 metre every year, meaning that from this point, 1 year later, if this is 2, this is 1, 1 year later, it's going to increase by 1. Now if this is at 0.5, an increase of 1 is going to put us up to 1.5. Okay? And that is why I put this 1, 1.5 coordinate here. What we essentially have now is enough information in the graph to come up with an equation. Because we've got 2 points, we can calculate the slope. Once we've got the slope, we can substitute it into the original or the general form for a straight line, and go about solving for the y-intercept by substituting one of these 2 points in for x and y. So the first of which we had to define our equation for a straight line, and I've noted that this is what I'm going to call equation 1. And then solving for m using our formula for slope or formula for gradient, and substituting these points for x1, y1, x2, y2 into this gives me this. And simplified will give me 1 over 1. 1 divided by 1 is, of course, 1. I can then take that 1 and substitute it back into equation 1, which will give me y equals 1x plus c. Because 1 multiplied by x is just x, we don't need to write the 1. So you can express it as just y equals x plus c, which I've then called equation 2. We can then go about solving for c by substituting a coordinate. I'm going to use 1 and 1.5 into equation 2 to solve for c, this unknown. So we're going to put this into this to solve for this. That's what I've done here, and rearranging to solve for c will give me 0.5. I can then substitute that c value of 0.5 back up to this equation, and you'll note I've then solved it because I've got a value for c, I've got a value of 1 for x, which is what I do, and I call it equation 3. Now, once I've got that equation, I can essentially calculate any x, y value given an x value or a y value. So if I get given y, I can calculate x, and likewise if I get given x, I can calculate y. And that's important to answering the actual question, which is asking how tall will the tree be in 10 years? Now 10 years is a time, which is here on the graph on our x-axis. Therefore the x we are given as 10, and it's asking us to solve for y given x equals 10. So what I've written is to find how tall the tree will be after 10 years, we sub that value of x equals 10 into equation 3 right here, which is our equation for the straight line, to solve for y, which is our height. So we'll calculate the height by substituting this into this. And if we do that, we get left with y equals 10 plus 0.5, which is simply 10.5 metres. Therefore, the tree will be 10.5 metres tall in 10 years after being planted. You can check that against your graph. So if you look at the 10-year mark, here we are, and we go up and across, you'll note that it does occur at 10.5. Okay, so it does match up on our graph nicely as well. But you can imagine that if it was asking for how tall the tree was, say, in 56 years, this graph might have to be substantially bigger, and you might not actually want to draw it, in which case you would have to just algebraically solve as we did using this process. Okay, but it is handy if your graph does encapsulate that point which is being asked about, or which is under question, that you double check it across, or double check it against your graph. So we have answered the question